What is energy? You hear the word all the time. I have no energy today, or that light bulb saves energy. In science, it has a very specific meaning. Energy is the ability to do work or cause a change. It's the stuff that makes things happen. Think about it. Energy is what makes a car move, what heats your food in the microwave, and what powers the screen you're watching this on. Without energy, the entire universe would be completely still, dark, and cold. It's the ultimate go. Button for everything, and it can change from one form to another, like electricity becoming light and heat in a bulb. So why do we even need to talk about energy? Because our entire modern world is built on it. Look around you. The lights in your room, the charge in your phone, the air conditioning or heater keeping you comfortable. That all runs on electricity, which has to come from somewhere. And it's not just electricity. The car or bus that took you to school runs on gasoline. The food you ate for breakfast was grown on a farm using tractors and shipped to your store in a truck, all using fuel. We need a constant, reliable supply of energy just to live our normal lives. When we look at all the different ways we get that energy, it can seem complicated. We hear about solar, wind, oil, coal, and nuclear. But the good news is we can sort all of them into just two simple categories. The first category is non-renewable, and the second is renewable. The only difference between them is whether or not they run out. Think of it like this. One group is like a gift card with a limited amount of money on it, and the other is like a piggy bank that magically gets new coins added to it every single day. Let's talk about that gift card first. Non-renewable energy. These are the energy sources that are finite. That means there is a limited supply, and once we use them all up, they're gone for good, or at least gone for millions and millions of years, which is how long it takes for them to form. It's like a giant underground savings account that nature saved up for us over a huge span of time. We are spending that savings way faster than nature can make any new deposits. That's the key idea. We're using them up and they're not coming back. The most famous non-renewables are the fossil fuels. They get that name for a simple reason. They are made from the fossils, the ancient buried remains of living things. We're talking about plants, trees, and tiny little ocean creatures that lived hundreds of millions of years ago, long before the dinosaurs. When they died, they got buried under layers and layers of mud, sand, and rock. Over millions of years, the intense heat from deep in the earth and the crushing pressure from the rocks above cooked and squeezed them into the fuels we use today. The three big ones are coal, oil, and natural gas. The first fossil fuel is coal. This is that black rocky stuff you've probably seen. Coal is the result of giant plants and trees that died in ancient swamps. Instead of rotting away completely, they were buried and compressed, and all that plant energy got locked inside. Today, we dig coal out of the ground in mines. Its main job: we burn it in huge power plants. The fire boils water, which creates high-pressure steam. And that steam spins a giant fan called a turbine to generate electricity for our cities. Next up is oil, which is also called petroleum. This isn't from swamp plants. It's mostly from tiny marine organisms, like algae and plankton, that died and sank to the bottom of ancient oceans. Like coal, they got buried and cooked for millions of years. Oil is a thick, black liquid that we pump out from deep underground, sometimes even from under the ocean floor. We can't use crude oil directly. We have to send it to a refinery, which is like a big factory that boils it and separates it into different, more useful fuels, like gasoline for cars, diesel for trucks, and jet fuel for airplanes. And a cool side fact: the plastics in your phone, your backpack, and your water bottle are also made from oil. The third fossil fuel is natural gas. This is a gas that's invisible and has no smell. The gas company actually adds that rotten egg smell so we can detect a leak. It was formed the same way as oil, from those same tiny sea creatures, and you often find it trapped in pockets of rock right above oil deposits. We use natural gas for a lot of things. Many people have a gas stove for cooking or a gas furnace that heats their home in the winter. Like coal, power plants also burn natural gas to spin turbines and generate electricity. It's called the cleanest fossil fuel because when it burns, it releases less pollution than coal or oil. But it's still a fossil fuel and it still pollutes. Now, there's one more major non-renewable source, but it is not a fossil fuel. That's nuclear energy. Nuclear power doesn't come from ancient plants or animals. It comes from a specific type of metal found in the ground called uranium. Nuclear power plants don't burn anything. Instead, they use a process called fission, where they split the uranium atoms apart. This releases an incredible amount of heat, which, just like in a coal plant, is used to boil water, create steam, and spin a turbine. You can get a massive amount of electricity from just a tiny, tiny amount of uranium. So let's sum up non-renewables. Why do we use them so much? The pros are that they are very powerful and reliable. You can run a coal or nuclear plant 24 hours a day, 7 days a week, and they produce a ton of energy. They've also been relatively cheap and easy to get for a long time. But the cons are a really big deal. First, they're going to run out. Second, burning fossil fuels releases gases into the atmosphere that cause air pollution and are the main driver of global climate change. And third, there's the risk of accidents. An oil tanker can spill and destroy an ecosystem, and a nuclear plant creates dangerous radioactive waste that we have to store safely for thousands of years. Okay, let's talk about the other category, renewable energy. This is the piggy bank that magically refills itself. These are the energy sources that are infinite. They are not going to run out on a human timescale. They are naturally replenished or renewed all the time. The sun comes up every morning, the wind blows, and the rivers flow. Because they don't produce the same pollution as fossil fuels, you'll often hear them called clean energy or green energy. The most obvious renewable source is solar power. This is energy that comes directly from the sun. The sun is a giant nuclear reactor in the sky, and it's constantly bathing our planet in energy. We can capture this energy in a couple of ways. The most common way is with those dark, shiny solar panels you see on roofs or in big solar farms. These are called photovoltaic or PV cells. They have a special material inside that, when sunlight hits it, knobs electrons loose and creates an electric current. It's like magic, turning sunlight directly into electricity with no moving parts. Next is wind power. This is really just another form of solar energy because it's the sun's uneven heating of the earth that causes air to move around, creating wind. For centuries, we've used wind to push sailboats and turn windmills to grind grain. Today, we use gigantic wind turbines, which look like massive, sleek windmills. When the wind blows, it spins these huge blades. The blades are connected to a box at the top called a nacelle, and inside that, a generator, much like the one in your car, converts the spinning motion into electricity. Hydropower is energy from moving water. Just like wind, this is also powered by the sun. The sun's heat evaporates water from the ocean, it forms clouds, and it rains or snows on high ground, forming rivers that flow back to the sea. We can capture the energy of that moving water. The most common way is with a giant dam. A dam blocks a river and creates a huge lake or reservoir behind it. Then, operators let small amounts of water flow through tunnels in the dam. As the water falls, it spins a turbine, just like wind or steam, and generates electricity. Hydropower is energy from moving water. Just like wind, this is also powered by the sun. The sun's heat evaporates water from the ocean, it forms clouds, and it rains or snows on high ground, forming rivers that flow back to the sea. We can capture the energy of that moving water. The most common way is with a giant dam. A dam blocks the river and creates a huge lake or reservoir behind it. Then, operators let small amounts of water flow through tunnels in the dam. As the water falls, it spins a turbine, just like wind or steam, and generates electricity. Finally, we have biomass energy. Bio means life, and mass means stuff. So this is energy from life stuff, any organic material. This is actually the oldest form of energy humans ever used. The first time a caveman burned a stick for warmth, that was biomass energy. Today, we still do that, but on a bigger scale. Power plants can burn wood chips, leftover crops, or even specific types of garbage to create steam. We can also take plants like corn or sugarcane and, through a chemical process, turn them into liquid fuels called biofuels, like ethanol, which can be mixed with gasoline to power cars. So, what's the verdict on renewables? The pros are huge. They are clean. They don't release the pollutants that cause climate change, and they are sustainable. The sun isn't going to stop shining anytime soon, and the wind won't stop blowing. But they have cons too. The biggest one is that many are intermittent. That's a key word. It means they don't work 24/7. Solar panels don't work at night, and wind turbines don't work if it's not windy. This means we need good ways to store the energy, like big batteries. They can also be expensive to build, and wind or solar farms can take up a lot of land. Here's a super important rule for all of physics: the law of conservation of energy. This law states that energy cannot be created or destroyed. It can only be transformed, that is, change from one form to another. You don't make electricity. You transform other energy into electricity. Think about the hydropower dam. The water held back in the reservoir has potential energy, stored energy. When you let it fall, it becomes kinetic energy, energy of motion. As it spins the turbine, it becomes electrical energy. The energy just changed its outfit, but the total amount is still the same. You'll often hear two words: conservation and efficiency. They sound similar, but they're different. Energy conservation is the simple act of using less energy. When you turn off the lights, when you leave a room, or unplug a charger you're not using, or choose to walk instead of drive, you are conserving energy. It's about your habits and choices. Energy efficiency is about using smarter technology to get the same job done with less energy. An old-fashioned incandescent light bulb used most of its energy to make heat and only a little to make light. An LED bulb is much more efficient. It turns almost all its energy into light, not heat. You still get a lit room, but you use way less power. So where does that leave us? Our world is at a big turning point. We know that relying 100% on non-renewable fossil fuels isn't sustainable forever. The future is about finding the right energy mix, using renewables like solar and wind more and more, while also using our existing fuels as cleanly as possible. And that's where you come in. The most important parts of this future are conservation and efficiency. The cheapest, cleanest energy is the energy you don't use in the first place. Every time you make a smart choice, like turning off a video game console or supporting companies that use efficient technology, you are helping to decide what our energy future looks like.